Hello everyone. Today I am going to discuss the second part of quadratic equation where I'll be discussing about the nature of roots, following which we'll be discussing problems based on nature of the roots and also the application based problems. Let's start with the nature of roots. So as in our last session we had discussed that for a quadratic equation at most two roots exist and we can find out the value of x using the quadratic formula as x equals to minus b plus minus square root of b square minus 4ac upon 2a, which also can be written as minus b plus minus root d upon 2a, where d is equals to b square minus 4ac. Now here the value of x is minus b plus root d upon 2a, or x equals to minus b minus root d upon 2a. Now when we talk about the nature of these two roots, then we can discuss whether they are real, and if they are real, then whether they are equal or they are unequal, and if they are not real, then what it is. And it all depends on the value of d, as d lies within the square root. So the value of d can be positive, 0, or it can be negative. So we will discuss it into three parts. That is, first, when d is greater than 0. We know when d is greater than 0, a square root of d will be a real number, and in that case the value of x will be different. So here we can say roots are real and distinct. Distinct also we can say it as different or unequal. Second, when d is equal to 0, then we know the value of square root of d will be 0. So the value of x will become minus b upon 2a in both the case, and so the value of roots will be equal. So we can say here roots are real and equal. Next, when you talk about the third case, that when d is less than 0. Now when d is less than 0, we know that the square root of d, it will be a square root of a negative number, and we cannot find the value of a square root of negative number in terms of real values. So we'll say that roots are not real, or also we can say here it as roots are imaginary. So this is how we can categorize the types of roots based on the discriminant value. So remember, the D stands for discriminant. Now once we know about the nature of the roots, let's solve some question which is based on it. So you have to find the nature of the roots of the following quadratic equations. So in order to find the nature of the roots, we are going to find the value of d first. So we will find out a is what? Here 2, b is minus 3, and c is 5. The value of d will be b square minus 4ac, which will be minus 3 square minus 4 into 2 into 5. That will be 9 minus 40, which is negative 31. And as negative 31 is less than 0, we can say therefore roots are not real. Then the second question, the equation is 3x square minus 4 root 3x plus 4 equals to 0. So here the value of a will be 3, b is minus 4 root 3, and c is 4. So the value of d will be b square minus 4ac, which will be minus 4 root 3 whole square minus 4 into 3 into 4. So minus 4 root 3 whole square will be 48, minus 4 into 3 into 4 will be also 48, which is equals to 0. So we can say therefore roots are real and equal. The next question is, find the value of k if the roots of the quadratic equation kx into x minus 2 plus 6 are equal. So in this case, already they have given the roots are equal. So we are going to use the condition that, as we know that if d is equal to 0, then roots are real and equal. And if here roots are equal, we can say discriminant value will be 0. So we'll say since roots are equal, therefore d will be equals to 0. And so that will be b square minus 4ac will be equals to 0. Now our equation is not in the standard form. So let's rewrite that in the standard form first. So we have kx into x minus 2 plus 6 equals to 0, which we can write it as kx square minus 2kx plus 6 equals to 0. And here the value of a is equals to k, the value of b is minus 2k, and the value of c is 6. Now on substituting these values, here we'll get minus 2k whole square minus 4 into k into 6 equals to 0, which will be 4k square minus 24 k equals to 0. Here we can take 4k common, that will be k minus 6 equals to 0. Now either 4k will be equals to 0 or k minus 6 will be equals to 0. On solving it, we'll get k equals to 0 or k equals to 6. Now we know that since k is the coefficient of x square, it cannot be 0. Here k cannot be 0 as it is the coefficient of x square. So therefore the value of k will be equals to 6. Next question is, find the value of m for which the equation m minus 1 into x square plus 2 into m minus 1 into x plus 1 equals to 0 has two real and equal roots. Again, we'll say since roots are real and equal, therefore d will be equals to 0, which we can write it as b square minus 4ac equals to 0. As in this case here, the value of a will be m minus 1, the value of b is 2 into m minus 1, and the value of c is 1. On substituting these values, we'll get 2 into m minus 1 whole square minus 4 into m minus 1 into 1 equals to 0, which will be 4 times m minus 1 square minus 4 into m minus 1 equals to 0. Now here we can take 4 into m minus 1 common, we'll get m minus 1 minus 1, which will be equals to 0. And so we'll get m minus 1 equals to 0 or m minus 2 equals to 0, which implies m will be equals to 1 or m will be equals to 2. Now again, here if you'll check that when m is 1, m minus 1 will become 0. So it's not possible as it is a coefficient of x square. Now therefore what will be the value of m? Therefore m will be equals to 2. Now the question is, find the value of k for which the roots of the equation 3x square minus 10x plus k equals to 0 are reciprocal of each other. Now here the roots of the quadratic equation and the zeros of the quadratic polynomial are same. So as we have discussed in the polynomial chapter, the relationship between the zeros and the coefficient, the same relationship is applicable even for the roots of quadratic equation. So we can say here for the quadratic equation that sum of the roots will be equals to minus b by a and the product of the roots will be c upon a. So using that, we have 3x square minus 10x plus k equals to 0. Here we'll say let roots be alpha and 1 upon alpha. So we can write therefore product of roots will be equals to c upon a, and that will be equals to alpha into 1 upon alpha is k upon 3, which implies 1 will be equals to k upon 3, and so the value of k will be equals to 3. Next we'll talk about the word problems. Now here we are going to solve some word problems or application based problems. So the first question is, find two consecutive positive integers, sum of whose squares is 365. So here let the two consecutive positive integer be x and x plus 1. Then according to the question, we can write x square plus x plus 1 whole square equals to 365. Now when we simplify, we'll get x square plus 2x plus 1 equals to 365, which will be 2x square plus 2x minus 364 equals to 0. Taking 2 common, we'll get x square plus x minus 182, which will be equals to 0. That means we'll have x square plus x minus 182 equals to 0, as 2 cannot be equals to 0. Now splitting the middle term, we are going to factorize it and then we'll find the values of x. For that, we'll be prime factorizing 182 factors. We have to group into 2 such that their sum or difference should come 1. So we'll take it as 7 into 2, 14 and 13. So we'll split x as plus 14x minus 13x minus 182 equals to 0. So from here we can write x common, x plus 14 minus 13 common, it will be x plus 14 equals to 0. So we'll get here that x plus 14, x minus 13 equals to 0. Now, which implies x plus 14 equals to 0 or x minus 13 equals to 0, which will give x equals to minus 14 or x equals to 13. Since we have to take positive integer, x equals to minus 14 will get rejected. So therefore, positive integers are 13 and 14. Next question is, the altitude of a right triangle is 7 cm less than its base. If the hypotenuse is 13 cm, find the other two sides. So it is a right angle triangle. Let us suppose this is ABC. And it is given the altitude of the right triangle is 7 cm less than its base. So let the base length be x centimeter, then altitude will be equals to x minus 7 centimeter. Now it is given that the hypotenuse is 13 centimeter. So by using Pythagoras theorem, we can write AC square equals to AB square plus BC square, which can be written as 13 square equals to x minus 7 square plus x square, which will be 169 equals to x square minus 14x plus 49 plus x square, which will be equals to 2x square minus 14x minus 120, which is equals to 0, which is equals to 2 into x square minus 7x minus 60 equals to 0, and we can write it as x square minus 7x minus 60 equals to 0. Now we'll split the middle term minus 7 into two parts. So we can write it as x square minus 12x plus 5x minus 60 equals to 0, which will be x common, x minus 12 plus 5 common, x minus 12 equals to 0, which will be equals to x minus 12 into x plus 5 equals to 0. So we'll get x minus 12 equal to 0 or x plus 5 equal to 0. So this will give the value of x as 12 or x will be minus 5. Now minus 5 will get rejected as the side cannot be negative. So therefore, sides are 12 centimeter, 5 centimeter, and 13 centimeter. The next question is, Rohan's mother is 26 years older than him. The product of their ages in years 3 years from now will be 360. Find their percentage. So in this case, let the Rohan's age be x years. Therefore, mother's age will be equals to x plus 26 years. Now this is given that the product of their age is 3 years from now. So after 3 years, Rohan's age will be equals to x plus 3 years and mother's age will be equals to x plus 29 years. And it's given the product of their ages will be 360. So according to the question, we can write x plus 3 into x plus 29 is 360, which will be x square plus 29x plus 3x plus 87 equals to 360, which we can write it as x square plus 32x minus 273, which is equals to 0. Now we'll split the middle term. So for splitting the middle term, we'll use the prime factorization of 273. So we can take it as 13 into 3, that will be 39 minus 7. So we'll split it as x square plus 39x minus 7x minus 273 equals to 0, which will be equals to x common x plus 39 minus 7 common x plus 39 equals to 0, which can be written further as x plus 39 into x minus 7 equals to 0. That means x plus 39 will be equals to 0 or x minus 7 will be 0, which implies x will be minus 39 or x will be 7. As age cannot be negative, it will be rejected. Therefore, Rohan's present age is 7 years and mother's present age is 33 years.